Okay, in this video I'm going to take you through how to draw an IPSO chart for this algorithm here. So the algorithm is an algorithm to output the 5 times table, and it says here a program is being written to help students with multiplication. An algorithm is needed that outputs the 5 times table up to and including a certain number. Okay, so let's think about, start off by thinking about our inputs that we would need for this algorithm. The inputs that we're going to need, the only input that we're going to need is the number that we need to finish at. So the user is going to enter a number, and at that point we're going to stop outputting the 5 times table. So we're going to output the 5 times table up to and including that point. So just as an example then, if the number that we entered was 20, our program would output 0, 5, 10, 15 and 20. If our limit was instead 19, so it could be a number that is not a multiple of 5, our program would output 0, 5, 10, 15, but not 20, because 20 is more than our limit, and we've said that we want to stop outputting multiples of 5 if they're more than 19. Okay, so that's our input. It's a limit, and it's the point at which we stop outputting multiples of 5. We've looked at our output there, just in those examples of what the algorithm does. So our output is the multiples of 5 up to and including, if our limit is a multiple of 5, our limit. So let's type that in. So our output is the multiples of 5 starting from 0 up to and including the limit if the limit is a multiple of 5. Going back to the 19 example, that didn't print 19 because 19 isn't a multiple of 5, so it's only going to print the limit if the limit is a multiple of 5, because we're only printing multiples of 5. Okay, moving on then to look at our processes. First of all, we're going to need a process that adds 5 to the current multiple. So we need to keep track of what the multiple of 5 is that we're currently on, as we're increasing through the 5 times table. And one process that we need is to add 5 to that, so that we can move on to the next multiple of 5. The second process that we're going to need is a check. So we're going to, in order to break out of our loop, when we've printed out all of the multiples of 5 from 0 up to the limit, we're going to need to check each time if the current multiple is less than or equal to the limit. If the current multiple is less than or equal to the limit, we want the algorithm to keep going, because we want it to print out that multiple and then add 5 to the current multiple. So we've got two processes. We're adding 5 to the current multiple each time our loop executes, and that's enabling us to print out the next value in the 5 times table. We're also checking each time if the current multiple is less than or equal to the limit, because if it's not, if it's more than the limit, then we need to stop, because that's the point at which we need to stop printing multiples of 5. Thinking about our storage then, the first thing we need to think about when it comes to storage is the inputs, because if we have taken something in as an input, we need to be able to store it to be able to do anything with it. So we need to store our input, which is the limit. So we need to store the limit that we've taken in. And secondly, we need to store the current multiple, because we need to keep track of that to be able to print out the multiples of 5. If we didn't keep track of that in our algorithm, we wouldn't know which multiple of 5 we were on, so we wouldn't be able to keep outputting the multiples of 5. So we need to keep track of the current multiple. We need to store that for our algorithm to work. Okay, so that's our IPSO chart for this algorithm completed. The final thing I want you to do when you've finished completing these IPSO charts for algorithms that contain loops is I want you to look at your processes and highlight any processes that will need to be repeated. If I look at my processes for this algorithm, I can see that the first one, adds 5 to the current multiple, is going to need to be repeated because every time I want to print out the next multiple, I need to work out what it is, and in order to do that I need to add 5 to the multiple that I've just printed out. So I'm going to highlight that process. And then I need to look at the next process that I've got, the second process here, and think about whether that needs to be repeated. And it will need to be repeated because every time my loop executes, in order to know whether I need to stop, I need to check if the current multiple is less than or equal to the limit. So that's going to need to be repeated as well. And by highlighting the processes that need to be repeated, it will help you when you come to representing the algorithm using a flowchart, pseudocode, or Python code to know which processes need to be included as part of your loop.